Hello, my name is Arun John and I'm a systems engineer at Dell Technologies. Today, I'll go through a demo on how to install PowerProtect Data Domain Virtual Edition in the cloud, specifically in AWS. Now, before we begin, let's look at a typical backup workflow onto a data domain system. We have some workloads in the cloud which we want to protect. We install a protection software and configure policies and schedules to drive the backups of these applications onto the data domain system. Now, the data domain system will manifest itself as an EC2 instance in AWS and will store all the metadata related to the backup in block storage or EBS in AWS terminology. It will also store all the backup data on object storage in S3. Here is a high-level architectural diagram of how we are going to deploy DDVE for our demo. We will first create a VPC followed by two subnets, a public subnet and its associated security group for hosting the Bastion host or the jump host. Our jump host will be Windows based. We will then create a private subnet and its associated security group for hosting our data domain system. We will launch data domain using AWS CloudFormation template. We will also create Internet Gateway or IGW for internet traffic and route tables to define the associated routes within the VPC and outside of the VPC. Finally, we'll create S3 bucket and S3 endpoint so DDVE can store all its backup data on the bucket through private connections. As a final step, we will then go ahead and connect to our data domain system using its UI and also SSH into it. Let's go ahead and deploy our data domain virtual edition. I have now logged on to the AWS console. In step 1, we will go ahead and create a virtual private cloud or VPC. Now, an Amazon VPC is a service that lets you launch AWS resources in a logically isolated virtual network that you define. So in order to create a VPC, we go ahead and say VPC. By default, AWS already creates a VPC. We'll go ahead and create a new VPC for the purpose of this demo. So we say create VPC, or we'll give it a name. We'll give it a CIDR range, which defines the number of IP address which we can have within this VPC. We'll leave all the other options at the default value, and we say create VPC. We have now created a VPC and we named it Demo VPC. In step 2, we'll go ahead and create some subnets. Now that we have created our VPC, we will go ahead and create two subnets, a public subnet for our jump host and a private subnet for our data domain system. To do that, we click on subnet and we say create subnet. We select the VPC. In our case, it's the demo VPC. We'll give it a name and we'll choose the availability zone. In our case, we'll choose the US East North Virginia 1C. We'll give it a CIDR range. We'll leave all the other options at the default value and we say create subnet. Similarly, we'll go ahead and create another subnet, which is the private subnet for our data domain system. Again, we choose our VPC. We'll give it a name. We'll choose the same availability zone as we did for previously. We'll give it a CIDR range and we say create subnet. We have now created two subnets. Again, a public subnet for our jump host and a private subnet for our data domain system. In step 3, we will go ahead and create some route tables. Now, route tables contains a set of rules that are used to determine where network from your subnet or gateway is to be directed. So let's go ahead and create some route tables. Now, by default, each time you create a VPC, AWS automatically creates a route table for us. So in our case, when we created the demo VPC, a route table was automatically created. What we'll do is we'll use that as our public route table. So we'll go ahead and name it public route. Similarly, we'll go ahead and create another route table for our private subnet. We'll name it private route. We'll choose the VPC, which is our demo VPC, and we'll say create. We have now created two route tables, a public route table for our public subnet and a private route table for our private subnet. What we'll now do is we'll associate the subnets to each of these route tables. So let's choose the public route. If you click on subnet associations and say edit subnet association, Both the subnets are listed here. What we'll do is we will select the public subnet and associate with the public route. We'll say save. Similarly, we'll go back to the private route table, go to edit subnet association, pick the private subnet and associate it with the private route, and then we click save. We have now finished creating two route tables and associated the route tables with its subnets. In step 4, we will go ahead and create an internet gateway, or IGW in short. Now, what makes a public subnet public is its ability to route traffic to the internet. Now, as it stands, if you look at the route table of the public subnet, all traffic is routed within the VPC and for that CIDR range, which ends with 10.0.0/26, which means to say no traffic can go out from the subnet to the internet, or no traffic can come from the internet to the subnet. This is of no use for us. So let's go ahead and create an internet gateway and attach it to our public route. To do that, we'll click on Internet Gateway and say create Internet Gateway. We'll give it a name. We say create Internet Gateway. We'll then go ahead and attach it to our VPC. We select our VPC, the demo VPC, and we say attach Internet Gateway. We'll then go back to our route tables, click on public route and edit routes, and we say any traffic which is not within the CIDR range should go to our internet gateway. Once we have selected that, we say routes. What we've done right now is we've created an internet gateway and attached it to our public subnet and updated the public route to reflect the internet gateway. In step 5, we'll go ahead and create some key pairs. So why do we need to create a key pair? If we want to access any virtual machine in AWS, we need to authenticate with a private key that corresponds to the public key of the virtual machine. Because our data domain and our jump host are going to be virtual machines, in order to access it, we need to create some private keys. So let's go ahead and do that. To do that, we click on key pairs, say create key pair. The first key pair we're going to create is for our data domain virtual edition. We'll name it DD key. We'll say create key pair. We'll do another one for our jump host. We'll name it, our jump host is going to be Windows based. After we give it a name, we say create key pair. So we have now created two key pairs, one key for our data domain and one key for our jump host. We need to save this key for our future use in our demo. In step 6, we'll go ahead and create security groups. Now, security groups acts like virtual firewall. This controls the inbound traffic to the EC2 instances and outbound traffic out of the EC2 instances, which in our case are the jump box and the data domain virtual edition. So let's go ahead and create security groups. So to do that, we'll click on security groups and we say create security group. Now the first security group we're going to create is for our jump box. So we'll give it a name. We'll give it a description. We'll choose the VPC where this security group is going to be launched. Now, if you look at the inbound rule, the inbound rules by default does not allow any traffic. This is of no use for us. So what we'll do is we'll click on add rule and we say allow all traffic from anywhere. Now our jump box is going to be Windows based, so we need to allow RDP, but instead of specifically saying RDP, I've selected all traffic, which includes RDP as well. If you look at the outbound rule says all traffic is allowed to anywhere, which is good. We don't have to make any changes there. We say create security group. So before that, we'll go ahead and give it a name, or a tag, I should say, and then we say create security group. We'll do a similar thing. We'll go ahead and create a security group for our data domain system. We'll give it a name. Go ahead and give it a description, and again choose the VPC. And the inbound rules, again by default nothing is allowed. We need to be aware that our data domain system is going to be in a private subnet, so the only host which needs to access the data domain virtual edition is our jump box, which is in the public subnet. So we need to keep that in mind, and we need to add the rules accordingly. So what we'll do is we'll click on add rules and we'll say allow all traffic but coming specifically from our jump box. So therefore, we select the security group of the jump box, which is jumpsec. We look at the outbound rules. The outbound rule says all traffic is allowed to anywhere, This includes HTTPS as well. So we don't have to make any changes there. We'll go ahead and give it a tag. We'll say name. We'll say DDVE sec. We'll say create security group. What we've done now is we created two security group, DDVE sec and jump sec, for our data domain system and our jump box respectively. And we have also edited the inbound and the outbound rules for each of these security groups. In step 7, we'll go ahead and create a S3 bucket. We create a S3 bucket for data domain to store the backup data. In order to do that, we click on S3 and we say create bucket. We give it a name. Now the name of the bucket has to be unique, because although we're creating the bucket in a region, which in our case is US East North Virginia, the buckets are global resource and therefore the name has to be unique. Once we have given it a unique name, we leave all the other options at the default value and we say create bucket. We have now created a bucket for our data domain system to store all its backup data. In step 8, we'll go ahead and create an S3 endpoint. And the reason why we create an S3 endpoint is so that our data domain virtual edition, which is in the private subnet, can talk to the S3 bucket using private network. To do that, we look for endpoints, choose endpoints, and then say create endpoint. Type in S3 and search. We'll get two options there. We'll select the gateway endpoint. We'll also make sure that we pick the right VPC where the endpoint is going to be launched, and then associate it with the private subnet, because that is where our data domain virtual edition is located. We'll give full access. We'll say create endpoint. Once we've done that, we'll go back to our route tables and check whether the endpoint is now listed as a route in the private route table. So if you click on route, you can see the endpoint is listed as one of the routes in the private route table. In step 9, we'll go ahead and create an IAM, or Identity Access Management policy. An IAM policy defines what actions are allowed by an AWS service. To create an IAM policy, we say IAM policies, create policy. Now policies are created using JSON. For the purpose of this demo, I have already created a JSON script, which basically is stating that any AWS service who has access to this policy, which we are about to create, can list, get, put, and delete new and existing objects in the S3 bucket. In our case, for the bucket named DDVE's bucket. We need to ensure the name of the bucket we specify here in the script is exactly the same as the name of the bucket we created in step 7. Once we have confirmed that, we say next. Again next, and we give our policy a name. Give it a description, and we say create policy. We have now created an IAM policy, and it should be listed in the list of IAM policies. In step 10, we'll go ahead and create an Identity Access Management role, or an IAM role. The way we attach a policy to an AWS entity is via roles. So let's create a role that assumes the policy that we created earlier. To do that, we click on IAM, roles, and we say create role. Now the AWS entity who's going to get the role is an EC2 instance, which is basically our data domain virtual edition. So once we have selected EC2, we click next. Then we look for the policy which we created earlier. We attach the policy to the role. We say next. We'll give our role a name. We'll give it a description, and we'll say create role. We have now created an IAM role. We need to take a note of the name of the role, because we will be using that in our future steps. In step 11, we'll go ahead and create an EC2 instance for our jump host. To do that, we will go ahead and click on EC2 and say launch instance. Now our jump host is going to be Windows based, so we'll select one of the Windows operating system from the free tier. We'll select the Windows Server 2019 base, say select. We'll click on configuration. We'll make sure that we select the right VPC and also the subnet. Again, the Windows host or jump host is going to be on the public subnet. So we pick the right subnet. We enable auto assign IP, public IP. We leave all the other options at the default value, and we say next. We'll leave the storage fields as is without making any changes. Go and add a tag. Call it as jump host. It's asking for a security group. We already created a security group, so we go ahead and pick our security group, which is our jump security. We'll go ahead and review and launch. We click launch. It's asking to pick a key pair. Again, we have already created a key pair for our jump host, if you remember. So we'll go ahead and pick the key pair, which is the jump key. Accept the agreement, and we say launch instance. Our jump host EC2 instance is getting launched. We will come back to it in a moment. As you can see, we finished creating the jump host. So what we'll do now is we'll go ahead and try and see if we can connect to our jump host. So to do that, we just click on connect, say RDP, and say download remote desktop. Say connect. It's asking for the password, so we'll go ahead and get the password. We'll go ahead and input our key, the jump key. We'll get the password, copy it, come back to the RDP session, paste the password, say yes for the certificate. We have successfully logged on to our jump host. Step 12, deploying Data Domain Virtual Edition. Now, because Data Domain is also software defined, we can instantiate an instance of Data Domain from the marketplaces of AWS. So in order to do that, we click on AWS Marketplace. We search for the latest version of Data Domain. We pick the latest version and we say subscribe. We accept the terms and condition and we'll wait until the subscription is complete. Now that we have finished subscribing to DDVE, as you can see, we can launch it using the AWS CloudFormation template. Now, the AWS CloudFormation template will allow you to create a virtual machine with predefined parameters like memory, CPU, storage, etc. So let's go ahead and deploy DDVE using the CloudFormation template. To do that, we click on Manage, Actions, and say Launch CloudFormation Stack. We choose the delivery method as CloudFormation, and we say Continue to launch. We choose the action, Launch CloudFormation, and say Launch. Click Next. We'll give it a name, the CloudFormation Stack a name. Next, we select the size of the data domain model we want to install. Now we have different options from 16 terabyte all the way up to 256 terabyte. For the purpose of this demo, I'm going to select the 16 terabyte, which allows me to install a data domain anywhere from 1 terabyte all the way up to 16 terabyte. Next is the size of the metadata disk. As discussed previously, data domain stores all its metadata on block storage or EBS. Now by default, the size of the metadata is, or the capacity of the metadata disk is about 10% of the size of the data domain model. And this is automatically provisioned by the CloudFormation template. And I'll show you that once data domain is up and running. Now, should you wish to provision a different capacity, you can do so by clicking on the drop-down menu. But again, for the purpose of this demo, I'm going to leave it at the default value, which is 10% of the size of the data domain model. We'll then give our data domain a name. We'll name it DDVE. We'll also give the role which we name of the role which we created earlier, which is DDVE role. The key pair. Thankfully, key pair is auto-populated. So the key for our data domain is DD key. We'll select that. We'll also choose the subnet ID. Now the subnet ID for our data domain is the private subnet. So we need to make sure that we select the private subnet and not the public subnet. So we select the private subnet. And then finally, we select the security group as well, which is DDVE security group. Once we have done that, we click next. We don't have to do anything here. We just leave everything as is and say next again. Here on the screen, it's asking us to confirm all the details we input into the CloudFormation template, like the name of the role, the name of the key, the size of the data domain model, the security group, etc. Once we've confirmed all that, we'll go ahead and say create stack. As you can see, the CloudFormation template is in the process of creating our data domain system. We will come back to this in a moment. As you can see, now the CloudFormation template has completed installing our data domain system. We can go ahead and check this in our EC2 dashboard. So what we'll do is we'll go to Service or AWS, click on EC2, and there should be an entry for our data domain system. Here you see our data domain system is listed and it's up and running. We can check whether it's up and running and ready to be logged on to by clicking on actions and looking at monitor and troubleshoot and say get instance screenshot. It is at the login page, which means to say we are ready to connect to it. But before we go there, what we'll do is we'll look at the volumes of the data domain virtual edition and see whether the metadata disk is automatically provisioned. So click on volumes, and if you look at it, there's 2 metadata disks automatically provisioned by the CloudFormation template for data domain to store all its metadata. In the next step, what we will do is we will try and log in to the UI of the data domain system from our jump host. Step 13, creating the data domain file system. What we'll do now is we'll log on to the jump host, and from the jump host we'll log on to the UI of the data domain system and create a file system for data domain. So I'm already on the jump host. What we'll do here is we'll open up a browser and then we'll type in the IP address, the private IP address of the data domain system, which is 10.0.0.23. It's asking for the username and the password. The default username is sysadmin, and the default password is the instance ID of the EC2 machine or the data domain. Now, for the purpose of this demo, I have changed the password to my own, so I'm going to use that. Again, the default password is the instance ID of the data domain system, right? If you want to see where you get the instance ID from, if you go to the EC2 dashboard and you go to the data domain system, and this is where you get the instance ID. Go back to our dashboard and we say log on. We are now logged on to the UI or the dashboard of the data domain system. It is throwing an error saying that file system does not exist. We will create that shortly. But before that, we need to go to administration, click on licenses and say replace license. We need to take a note of the node locking ID of the data domain system. Now this is very important because it is against this node locking ID the licenses are issued. For the purpose of this demo, I've already taken a note of this and I've given it to the Dell licensing team, who has in turn given me an 8 TB of DDVE license, which I'm going to apply shortly. I have received the license file and we'll go ahead and upload it. So we'll say upload. Say apply. The license file has been successfully imported and it's telling us that I have been licensed for 8 TB of data domain license. Now that we've imported the license, we'll go ahead and create the file system. In order to do that, we click on data management, file system, and then we say create file system. We'll give the name of the bucket, which is DDVE's bucket. We'll say next. We add the metadata disk for the data domain and we say next. I click on finish. The data domain system is in the process of creating the file system. The file system creation process is now complete. Here it is giving you some details about the data domain system we just finished installing in AWS, like the size of the data domain, the use capacity, etc. So this concludes the process of installing the data domain virtual edition in AWS. As a final step, what we will also do is we will try and SSH into this data domain system. To log on to the data domain system using SSH, what we do is we open a PuTTY session and give some details like the username and the IP address of the data domain. For the purpose of this demo, I've already saved those information. What we'll do is we'll go ahead and load it. It shows the username and the IP address of the data domain, which is 10.0.0.23. Once we've done that, I'll click on open. It is now successfully logged in to the data domain system using SSH. We can further see the size of the data domain system and the available capacity by typing the command filesys show space. This confirms that we can go ahead and log in to the data domain system using SSH. As you can see, in few easy steps, we installed Data Domain Virtual Edition in AWS and accessed it using its UI and also SSH'd into it. This concludes our demo. Thank you for listening.